Hi everyone, I'm Lao Wan, and today I'm going to be speaking to Thomas Mulaney about his upcoming book, The Chinese Computer. Thanks for joining me. How's it going?
It's great to be here. And yeah, thank you so much for being interested in the work.
No, it was so fascinating, and it's almost sort of like encyclopedic because it goes all the way back to like the telegraph era is apparently when the problems with Chinese computing started. And then you cover like all the way until modern pinging based, which I think is like what most of our viewers, like a lot of them speak Chinese, they're probably familiar with using like pinging based IMEs. But it was a lot to learn as I was reading through. Um, so yeah, could you explain how, for a lot of people, it's super obvious how typing works in Chinese, but there was
Mhm.
a long period when people didn't know if it was possible. Am I correct?
That's absolutely right. It now is self-evident. It's it's an everyday fact of computing and of new media in the entire Chinese-speaking world that this works, it functions. And what I try to explain in the book is that this taken for granted just fact of life, which exists today, was the outcome of an incredibly hard fought conceptual linguistic engineering puzzle that involved some of the most brilliant and eccentric minds from all over the planet. Really, it was a as a problem, it was kind of a super magnet that brought together some really colorful and interesting and brilliant characters that date all the way back to in the case of computing, date back to the immediate aftermath of the Second World War. And as you mentioned, if we think about the broader history in which computing is just one part, all the way back to the age of telegraphy with Morse code.
And I think before we jump all the way in to that era, the telegraphy and the first typewriter, we might need you to explain what an IME is, an input method editor.
Sure.
What is
So
that?
an input method editor is it's a software program that comes pre-installed on every single computer everywhere on Earth. If you buy it in, the Palo Alto Apple Store, if you buy it in Azerbaijan, all systems come preloaded with these things called IMEs. And an input method editor is sometimes referred to as middleware. It's a program that sits in between the user and whatever application they're using, Microsoft Word, email, web browsing. And its one and only job is to intercept all of the keystrokes that the user is making on their keyboard, to intercept them and analyze them, and then use those keystrokes to try to figure out what the user is trying to write in this case in Chinese, although IMEs are also used for Japanese and Korean and Arabic. But what it's doing is trying to take the QWERTY keyboard in the case of Chinese language computing and figure out what does a particular sequence of letters, Latin letters, and Arabic numerals, what Chinese character is the user trying to retrieve or find? And that's what the input method editor, that's its only job as a piece of software. And once it makes a match, once it figures out what you want and the user confirms, then it sends that information to the screen of Microsoft Word or to the Google search bar, to the Baidu search bar, to a message, to a friend, and sort of its job is done. But it's constantly operating in between what a user is typing and then whatever computer program is on the back end of that.
And it's probably this in-betweenness that I think makes a lot of people just forget it exists, right? Like I feel like a lot of Chinese typers will, for example, to type in 电脑, they'll type in DIANNAO and then they'll tap the little prompt that comes up above it, if that's the
Right.
correct format. But they're not aware that, I guess, of the middleware, which
Yeah.
was really interesting when you started I think it was maybe your second chapter of your book when you called it When IMEs Were Women, and you were talking about Grace Tong, and I think you posed it as a kind of a really intense tableau almost of her having to step up and perform this really intense task that's now we've completely mechanized it. It's all automated, no humans involved in that portion. Can you explain how the first typewriter, I think this was by Kao, the first typewriter was working, how she was actually typing on that? That was like, I find it hard to explain that to people on telling this about this book.
Yeah, so just by a little frame is that, every viewer for whom this is second nature, typing in Chinese is second nature, they'll know that a core element of input method editors is the pop-up menu. So in English language computing, there is the keyboard and then there's the screen. So it might be Microsoft Word or search, and you're typing, and the whole notion is that what you type is what you get, generally speaking. But that in Chinese language computing with input method editors, there are actually two screens all the time. There is Microsoft Word, and there's this pop-up menu that is playing this incredibly important role, which is this is the pop-up menu where the input method editor is making suggestions back to the user and effectively asking the user, if we could put it in anthropomorphic terms, is this the character you want? Is this the character you want? So Dian Na or something of that nature. Is this the Dian that you want? And so the user then has an opportunity to say, no, that's not the one I want. I actually want a different Dian. Or yes, that is the one I want. And so it's this recursive, almost cybernetic loop that is part of IMEs today. But one of the earliest experiments with input was on the first electric Chinese typewriter, not the first Chinese typewriter in history, but the first electro-automatic that was designed by Gao Zhongqin in collaboration with the IBM Corporation back in the 40s. And on this machine, it had an internal metal drum, like a circular drum with Chinese characters etched on it in mirror image. And it was sort of like, think of it as a hard drive, almost a physical hard drive of Chinese characters. And then the keyboard had no Chinese characters on it at all. It had just Arabic numerals, just digits. And so in order to produce the character Dian on the page, you would have to enter a specific 4-digit code that then the machine knew that if you type this 4-digit code, the user wants Dian. But here's the trick, is that in the IBM Chinese typewriter, there was no pop-up menu. Either you got it right or you got it wrong. There was no opportunity for the typist to see the machine say, is this the Dian you wanted? You simply had to purely memorize it. And so I talk about these two individuals, Lois Liu, who is on the cover of the book, in fact, and Grace Tong. And these were early employees of the IBM Corporation whose job it was to serve as the demonstrator in very, very large public venues with sometimes hundreds and hundreds of journalists and onlookers. And they would be on stage and people would literally be yelling out Chinese characters. And either Lois Liu or Grace Tong, depending on the day, would, from memory, produce in their mind, the 4-digit code that corresponded to the Chinese character I was just asked, and then type it on the machine, and lo and behold, it would produce. So that's why I say that the first IME was a human being, an input method editor, because that whole process, that computational process, was taking place literally in Lois Liu's mind and body. And then only later did engineers start to create this secondary pop-up menu to make this cybernetic loop that now we're very familiar with.
So also about the digits, that is a hangover from Chinese telegraphy, and that was interesting.
Yes. So once the trick is, as you put it, the in-betweenness of input, the in-betweenness of 输入法, where you're placing a layer between the act of typing and then output of whatever ends up on the screen. Once you start experimenting in that in-between space, technically speaking, there are an infinite number of possible ways that one could map the letters of the Latin alphabet onto Chinese characters, or in this case, the way that one could map numerical codes to Chinese characters. You can do that mapping theoretically in an infinite number of different ways. They won't all be equally efficient, but they're all possible and available. And so what many of your viewers will likely not know, in fact, is that phonetic input, so pinyin input, was a very, very, very late comer to the story. For the greater part of the history of Chinese computing, Chinese 输入法, or input methods, were all structure-based. They were all based on the shape and structure of the written Chinese character, not on the sound. Because computer engineers, for decades, they were aware of the possibility of phonetic input. They thought it was absolutely the wrong way to go, least efficient. There were plenty of other options that were far more efficient. And one of these input methods that IBM used was patterned after the first ever telegraph code, Morse code, for Chinese, dating back to 1871.
And I remember in your book that it was just two people who happened to be in China, foreigners, Westerners who happened to be in China, that just decided to assign the most popular, most commonly used 2,000 characters some digits. And so there was a history.
Yeah. Effectively, yes. So electric telegraphy is spreading across the world. It is, it's beginning in the 1840s, 1850s. They're the most important telecom company in the story, cable and wireless, is deeply embedded in British Empire and expansion. There's a very important Danish company, and it is very much in their interest and in the interest of Europe in general and the UK and the British Empire to spread electric telegraphy. This is an incredible way to keep track of empire and markets. And so as the actual infrastructure starts to spread around the globe, like literally the cables and the poles and the telegraph stations, that's only part of the story, because you also need a code. You need the counterpart of Morse code with dots and dashes. Now, there are other writing systems, Cyrillic, used in Russian, Arabic, and other Arabic-derived scripts. These are actually not a big problem for telegraphy, because there are alphabets or syllabaries. There's a small number. But Chinese became, and this is really I argue, the origin point of the notion of Chinese as a problem, as a writing system, is how are we going to fit the world's one major non-alphabetic script with tens of thousands of characters into a system of Morse code that really depends upon the existence of letters to function. And these two foreigners, a French harbor master and a Danish mathematician, came up with what becomes the 1871 Chinese telegraph code, which, as you pointed out, takes the 10,000 most common Chinese characters, assigns a 4-digit cipher 0001 all the way to 9999, and then basically calls it a day. And then to send a Chinese telegram, what you do is you take the Chinese message, you translate it into this 4-digit cipher, and then you use Morse code to send the numeric ciphers across the wire. And then the person on the other end basically does the process in reverse.
Yeah. And then all of a sudden, with Kao, these women who had to perform in front of massive audiences were suddenly having to do the job of both people, which has sort of now become an IME. Am I summarizing that well?
Yeah, that's exactly right. I mean, it is effectively, it's like sending a telegraph, into the wire, but then it bends back and gets sent back to you. So you're both the sender and the receiver of the message. But a telegraph officer, a Chinese telegraph officer in any telegraph station across China in the 1880s and 90s and 1900s, all the way up to the 1960s and 70s, they had code books at their disposal, little manuals that quite literally had all of the Chinese characters organized by dictionary organization, so that you could look up the numbers, or you have the numbers and you can look up the characters. A figure like Lois Liu or Grace Tong had to have most of that code book inside their brain.
Crazy. Totally insane to think about having to do that. If you don't mind, would you want to skip forward to the 1960s? This was the part of your book. I'm a little bit of a sci-fi fan. And so then there are like the parts of it that really feel like cyberpunk, these massive keyboards that had to sprawl across rooms. And there are really great pictures in the book as well of like the Beijing system and also the IPX of ideographics. Can you explain what 120 degrees of shift means?
Yeah, so we're, in the QWERTY world, we're used to shift, the idea of going from lowercase to uppercase. And maybe if you throw in control or alt or function, the notion that the keyboard has layers, and it has maybe 2 layers or maybe 5, depending on how you count. In the case of Chinese keyboards, that is an era that I discuss in the book, in which, inspired by the microcomputing revolution, there are a number of engineers all around the world who, for a moment, for a good decade, decide to abandon input method altogether. They no longer want to confine themselves to thinking about, how do I use the QWERTY keyboard to enter Chinese? What they want to think about is, how could I build a keyboard from scratch that is tuned to the requirements of this writing system of Chinese? And so the two that you're referring to, one is comes out of mainland Chinese experiments with keyboard interfaces, and this is what's so-called the so-called large format keyboard. And this is it's a console, effectively. It's a keyboard with many hundreds of keys. And the idea here is that the QWERTY keyboard, although globally ubiquitous, the shape and size of the QWERTY keyboard, maybe not literally QWERTY itself, but the shape and size of the QWERTY keyboard is all around the world now. But from our standpoint as engineers worried about Chinese input, it's not the best choice, because it has too little real estate to make use of. We could really use more buttons. We could make use of that. And so why don't we try to imagine from scratch what a keyboard should or would look like if we thought of it in that way? Another, and this is the IPX system, which is arguably probably one of the most spectacular machines in the entire story, developed by a Taiwanese-American engineer who worked for IBM for a good portion of his career, but then broke off to work on Chinese text processing. And he developed a system that effectively had over 100 levels of shift. Let me try to visually explain this, or sort of gesturally explain this in a way that a viewer could understand. But imagine a grid of buttons, just like a regular keyboard, but that on each button, there's not just one symbol. There are 15 symbols. In this case, 15 Chinese characters per key. And so in order to type one of these Chinese characters, you don't just push the button. You also have to push one of 15 number keys, 1 through 15, to indicate which of those 15 Chinese characters you want. So each character requires two key depressions. First, you push a number, then you push the button on which that Chinese character is in position 1, 2, 3, 4, 10, 11, 12, 13, 14, 15. Okay, so already we're at 15 levels of shift already. But here's the cool part, is that the button is not actually printed on the surface of the key. It's actually a laminated booklet that quite literally sits on top of a blank grid of keys. You can remove this laminated booklet, the spiral-bound laminated booklet, and you'll see these empty keys. And you can turn the pages of this laminated booklet. You can literally turn the page to a different keyboard. And every time you turn the page, there are some of these booklets that have 4 pages in them. Some of these booklets have 8 pages in them. And so if you turn the page, there's another bank of keys, 1 through 4 or 1 through 8, that indicates what page number of the keyboard you are on. So let's say you turn to page 2 of the keyboard, you press 2, then you press one of the numbers 1 through 15, and then you push the number of the key that has the Chinese character you want. So even though the keyboard itself fits on top of a desktop, it's maybe 17 inches wide, I forget the exact dimensions, it can fit nearly 20,000, I think was the total count, Chinese characters, because there are 120 potential levels of shift as compared to the 2 levels of shift that we're familiar with in the realm of QWERTY. So just these engineering feats, this entirely changed newspaper publishing in Taiwan, the tax industry, the Yellow Pages industry. But eventually QWERTY struck back. The QWERTY keyboard did not die out in the Sinophone computing world. It eventually made a comeback starting in the late 70s and 1980s. And then that leads us to the present day where QWERTY keyboard is dominant across the entire Sinophone world, no matter which shurufa is being used.
Yeah, it's such a fascinating period with the massive, like it almost gives me a sense of nostalgia for a time I wasn't really alive in.
Yeah.
Yeah. I had a question about the personal computing revolution, and I think you also call it the death of hardware, and the period when Chinese people who were trying to figure out how to type on personal computers were having to hack the widely commercially available personal computers. Can you explain maybe what was missing from those computers that needed to be added, and also how people were coming across those parts?
Sure. So if you think about almost every chapter in the history of communication and information technologies from the 19th century onward has this recurring story, which that the initial technology is effectively overfitted, almost cellophane wrapped to the needs and requirements of English and the Latin alphabet. Alfred Vail, Samuel Morse were native speakers of English. One could hardly blame them that their imagination for Morse code was really tethered to the English language. The personal computing revolution begins, for our purposes in the United States, in the English-speaking world. In terms of text encoding, Wozniak and Gates and all of these sort of luminary figures that we think of at the beginning of this, Jobs and others, they are speakers of English. They have a big enough engineering problem and challenge in front of them. They don't want to make trouble for themselves, so to speak. And so they treat input and also text encoding as a simple story of we have 26 letters of the Latin alphabet, uppercase and lowercase, Arabic numerals, punctuation marks, certainly other command codes, and that's it. What we know of still to today as ASCII, the American standard code for information interchange. And so this then informs every other dimension of the personal computing revolution. The resolution of monitors, the resolution of dot matrix impact printers, how memory works, how keyboards function with the computer. So effectively, what it means is once you start to have the reform era, once you have the opening to the capitalist world of 改革开放, and you begin to have this trickle of personal computers entering into the Chinese market, largely at the beginning, it was largely institutions buying these, danwei, not individual buyers for whom it was beyond average income, but steadily these became more of a feature of everyday life. But the problem is that when you turn these machines on or you take them out of the box, the monitors out of the box can't handle Chinese characters. The printers out of the box can't print Chinese characters. The keyboard and the way in which the central processing unit handles keyboard input cannot out of the box handle input method editors. So it's every last feature and every peripheral, printers, monitors, and so forth, had to be modded or hacked in order to render them compatible with Chinese character input and output. So one very basic example is printing. So low resolution, so-called dot matrix printing or impact printing. This is a printer which largely doesn't exist anymore. But for any viewer of a certain age, you will remember the sound of a dot matrix printer. It's a series of tiny metal needles or metal pins that are inside a print cartridge. And there's a grid of pins that passes over the surface of the platen of paper. And there's an ink ribbon or some sort of inking mechanism. And then in a pattern of needle strikes, it will lay down a line of text across the page. Now, how many needles, how many pins do we need? If you're Steve Wozniak, if you're Wozniak or Jobs, you only need 9 pins. Why? Because it's been determined that all of the letters of the Latin alphabet and all of the numerals, Arabic numerals, punctuation marks, can be printed with sufficient legibility. Not pretty, but they are legible with a grid of 5 by 7. Or, so one line of a 9-pin or a 7-pin printer is sufficient for one entire line of English text. Well, what is the minimum resolution that one needs for a Chinese character?
Some of them are incredibly complicated.
Explanations? Yeah.
Oh, I was just saying that some of these Chinese characters are so much more complicated than a letter, right? There are multiple images.
Oh, they're all, probably 90+% of them need a minimum resolution of basically a 16 by 16 grid, something of that nature. And so how in the world are we going to effectively trick an out-of-the-box dot matrix printer that we purchased at the store at great cost? How are we going to trick it in order to be able to print Chinese characters? And there's a variety of methods that, these very, very technical and very sophisticated kind of thinkers within engineering are coming up with. But the answer is the out-of-the-box settings simply won't work, and everything has to be modded.
I had a couple more questions for you, but sort of more about Chinese computing in the present.
Sure.
So everyone's sort of increasingly used to pinging. I feel like maybe 95%. My dad, who's Chinese, types with pinging. But I recently just had a thought that if you type in pinging, you just expect to see the IME to give you options. Whereas in English, we're creating new words all the time, like lol, right? I mean, they're not really words, but what are the implications of sort of the set amount of options of an IME on the linguistic evolution for Chinese? Do you have any thoughts on that?
Does it inhibit that? I think that it allows for a different kind of playfulness with language. One could argue that it's entirely possible to coin a new Chinese character. That's the story of the 19th and 20th century. The entire periodic table of elements pretty much had to be coined from scratch. There was no Chinese term for plutonium, so someone had to sit down and make it. So the story of making new Chinese characters is still with us, and there's all of those very, very old story of how one makes a new Chinese character dating all the way back to the beginnings of writing itself. One could argue that because of the nature of Chinese digital writing, that it depends upon another script in order to function. That is the Latin alphabet or pen strokes or keystrokes or finger swipes, that it does raise the possibility of a more expanded repertoire of linguistic playfulness. I think you could make that argument as well, because slang allows, in Chinese internet slang, can use characters in unexpected ways, but it can also use the letters of the Latin alphabet in unexpected ways, and it can use them together in unexpected ways. So I would say that actually the palette of coining words and slang and neologism and so forth might actually be augmented or more expansive in the Chinese language context.
Thanks. That's actually a worry that I've been having on my own for a long time.
Don't worry about it. Don't worry about it.
I want to give the viewers the anecdote that I think you sort of started the whole book with about Huang Zhenyu's typing record, right? Because I think you say that in the era when people were figuring out how to create electric typewriters in Chinese, the word per minute rate was around 20. Is that high?
Somewhere in that order. Mm-hmm.
But then by 2003, I think, is when this competition was happening. Huang Zhenyu,
2013.
2013, mm-hmm. Right. Huang Zhenyu was able to type at 221 characters per minute.
That's right.
And I just did a quick Google, and the fastest English typist, Barbara Blackburn, achieved 212 words per minute. And I know that like when I've given these numbers to my friends, they're quick to say, look, characters and words are not necessarily the same.
I have a whole footnote about that. No, I know that there's going to be that response. I think there's a 500-word footnote to try to neutralize the counter argument of obviously characters and words are different, but there are ways, sort of tried and true ways to think about how many characters equal a word and so forth. You can sit down with a translator, a really, a skilled, experienced translator, and you can ask them, in your experience, if I were to give you a text of X characters, what on average is going to be the ratio once you put this into English. But the bigger issue or question is that if you go back to the era of the beginning of the story, I know in my two books, the Chinese typewriter and the Chinese computer, if you go back to the era of telegraphy, Chinese telegrams are unquestionably one of the slowest on the planet. They operate at such a profound structural disadvantage compared to basically any other writing system in existence. If you fast forward to typewriting, as much as I admire the Chinese typewriter as this incredible linguistic and engineering puzzle and feat, there is no Chinese typist who in the 1930s could go head to head with someone in typing in Italian or Cyrillic or Hebrew or English. And that story repeats itself, but then suddenly something quite dramatic has changed, which is that in this competition, which is just one of many examples I could have drawn from, but from this 2013 example of someone operating at a speed that far exceeds anything that is possible on a Remington electric typewriter, or even just using a word processor and a conventional QWERTY keyboard, that something profound has changed. And where did that change happen? When did it happen? How did it happen? But more importantly, how did we all not notice that it happened? Because you can still sit down with not a few, and by which not a few, I mean millions and millions of people for whom the baseline assumption is, if you were to describe how a shurufa, how an input method editor works, their first reaction will be, my gosh, that sounds slow. Or my gosh, that sounds cumbersome. My gosh, that sounds deficient compared to the amazing what you type is what you get immediate feeling of English language or Latin alphabetic computing. And then you might follow up and say, well, if it were, in fact, this utterly cumbersome and useless, you might be surprised to know about the typing, the rate that was achieved by Huang Zhenyu in 2013, or by the fact that there are more internet users on an active basis in the Sinophone world than there is, that's 3 times the population of the United States as a whole. And so what's amazing is that not only has this inversion taken place, but somehow the great majority of Earth, including many in China, including China, has somehow not noticed it. So the book is trying to explain how it happened, explain how it is that we missed it, and also try to make a case that the implications for the history I talk about in the book go far beyond just Chinese tech or the Chinese history. It has global historical implications for effectively what writing is in the digital age. I'm a big believer, after working on this book for 15 years, that the fundamental nature of writing in the digital age has changed, and yet we have somehow not noticed that we are already in a new epoch.
The nature of writing changing. Sorry, and we're almost at time, but it does remind me of the anecdote you have about 提笔忘字. Is that what it is? Where they lift the pen and then struggle to figure out how to write the character? I asked my dad if that happens to him, and he's like, yeah, all the time. I don't write handwritten notes anymore.
Of course. Yeah. But here's the amazing thing to ask your dad. Mm-hmm. It would be something along these lines: is take out a piece of. I mean, there are people who have tried to prove the decline or death of Chinese writing through the lens of TV Wangzi, to pick up the brush and forget the character. There are even folks who have, and these are largely foreigners, they'll sort of arrive in Beijing, they'll corner some poor person in the grocery store, they'll give them a pad of paper, and they'll ask them to write a Chinese character, and the person will struggle or will write some sort of misshapen graph. And the conclusion, the interpretive conclusion is, aha, the decline of Chinese writing in the digital age. What they should have done is then take out their iPhone, look at this misshapen character that the person just wrote, and copy it stroke for stroke, misshapen and all, into the trackpad. I'll bet you $10 that the IME finds the character that the person wants, meaning that it's not just that handwriting is getting bad or that people are forgetting. It's that the way we write now has a fundamental relationship with a form of technology. And so that person doesn't have character amnesia, isn't aphasic, isn't illiterate, isn't non-literate, isn't semi-literate. That person is fully literate, but their literacy and in many cases, the literacy of a lot more people than perhaps we're willing to acknowledge in the 21st century in the digital age, literacy is a relational thing with technology. And so, of course, if you turn off all the phones, you turn off Wi-Fi, you turn off the computer, and you say, okay, let's go back to a 20th century or a 19th century concept of writing, and let's see how you do. We're not going to do as well. But that's a little bit like handing a calligrapher from the Qing dynasty the tools that one would have used to etch characters into bronze and say, do your best. And then to look at the characters that they etched in bronze and say, my gosh, these are so ugly. I guess people are forgetting how to write. Language and writing is always related to the tools we use to produce that. And the tools we use to produce that now, at least in the Sinophone world, fundamentally include input method editors. Input is part of writing now, through and through.
I did also want to ask you about your new word. I think it's you who invented it, hypography. Did you coin the term?
Yes, yeah. I'd be happy to give you my quick definition of it. Effectively, over the course of researching the book, I spent 15 years on this book. I am allergic to neologism in general. If I can use a word that already exists, I am more than happy to do so. And for a long time, I tried to find a word to describe what it is that I was seeing in Chinese computing. In a nutshell, let's say for the sake of argument, there are 900 million internet users in mainland China alone. Every single one of them is sitting down at either a QWERTY keyboard or a trackpad. None of those 900 million people are touching a Chinese character in order to produce a Chinese character on screen or in an email or whatever. And so technically speaking, all 900 million of those computer and internet users, they are producing this immense transcript, trillions and quadrillions of characters long, that is technically full of letters of the Latin alphabet, Arabic numerals, and keystrokes of various sorts. But the weird thing is, and the fascinating thing is from the history of writing, is that in a blink of an eye, that huge transcript of letters and Latin letters and Arabic numerals disappears and is replaced with a secondary transcript of whatever Chinese passage they're writing, a text message, an essay, an email, whatever it might be. And it hit me, what do I call all of those letters, all of those Arabic numerals? What do I call the form of writing that is designed to disappear en route to a different goal? And I thought, okay, abbreviation, no. Acronyms, no. Emoji, no. Slang, no. I went through a list in my mind over years of dozens and dozens and dozens of terms from linguistics and writing and so forth. And it hit me that we actually don't have a word or a concept for the form of writing whose only purpose is to help a computational device find a character from memory. every digital writer in the Chinese-speaking world is a search writer. Everything that they're not typing in order to see that appear on the screen, unless they're typing in English, but they're not typing it to see it appear on the screen. They're typing it purely for the function of providing kind of criteria to this program, an input method editor, purely for the purpose of searching and retrieving the character they want. So what should we call this kind of writing? And that's when the terminology of hypography emerges. Those, think of hypothyroidism, or hypo, this
Underneath.
underwriting, whose only purpose is to become another kind of writing. And then from that point on, we just read it the way we would read Chinese characters, and have been reading Chinese characters for millennia. So that's why, as much as I fought it and didn't want to invent a new word, that ultimately it seemed that I needed to offer this up as part of the book to say, what do you think of this as a term for the concept that you're seeing in between the covers of this book?
It feels natural, if that helps. When I'm reading, it makes sense.
Cool. I know. I appreciate that. I worried about it for a very long time, and I gave talks where the audience may not have realized it, but my one and only concern was, do they think this is frivolous or unnecessary or just window dressing? Because there are a lot of academics invent words that they're decorative, but I really don't mean this in a decorative sense. There is something that's happening every single second of every single day. Like as we speak, hypographs are being produced. This interesting and fascinating form of writing that is designed to disappear. And there's no word that comes to mind that captures it. And so I'll be interested to see what readers do with that concept when the book comes out in May.
Yeah. Thank you so much, Thomas Mullaney. And the book is out in May. It's available for pre-order right now from, Amazon and all the other places. Thanks for joining me.
Thank you for having me.
Bye.